Welcome to the deep dive. Today, we're getting into something absolutely fundamental for anyone involved in rail engineering or safety. Seriously, if you build, design, operate, or even supply parts for a railway, this is core stuff.
Absolutely. We're talking about the foundations.
Yeah. Whether you're, an engineering student just wrapping your head around safety concepts, or maybe you're early in your career facing your first big design review, or even if you're just really into railway safety, this underpins everything.
It really does.
So the big question, what is the absolute non-negotiable requirement here, and why is it way more than just ticking compliance boxes?
It boils down to the duty of care. But it's crucial to understand this isn't just a nice idea, a moral thing. It's a serious legal obligation. And importantly, it's non-transferable.
Non-transferable. Okay.
And here's the kicker. What really sets rail safety apart.
Yeah.
It's not enough to just try to be safe. You have to prove it with documented, verifiable evidence.
Right. So that proof, that whole process of turning, let's say, good intentions and solid engineering into something legally solid, that's where system safety assurance comes in, SSA.
Precisely. SSA is that formalized, disciplined process. It's the engineering and management framework you need to take that fundamental duty and make it objective, make it provable.
Okay.
The core idea sounds simple, maybe deceptively so. Every single person or company with a duty, that's the operator, the designer, suppliers, installers, everyone, they have to first try to eliminate all foreseeable safety risks.
Eliminate them entirely. That's the first step.
Yes, and if elimination is genuinely, truly not possible, then they have to minimize those risks.
Yeah.
And that minimization effort, well, it's measured by a very specific phrase. So far as is reasonably practical, SFARRP.
Okay, that acronym feels like it's going to be central to this whole conversation. It sounds like the absolute baseline for effort, right?
It is the bedrock, the legal test.
But let's be real, especially for folks just starting out, SSA, SFARP. It can sound a bit like, bureaucracy, paperwork. Why is mastering this framework, this specific legal duty, so incredibly important right from the start of a career in rail?
Because fundamentally, it's the safety net. It's the guardrail.
Right.
SSA is the due diligence structure that, first and foremost, protects lives, employees, passengers, the public. That's paramount.
Of course.
But beyond that, on a professional and organizational level, it provides the absolutely essential paperwork, the documentation you need to justify every single engineering decision you make, from the first concept sketches through maintenance, all the way to getting rid of an asset years down the line.
So without it, an organization is just exposed.
Massively exposed.
Right.
Legally, regulatorily, SSA is the language of safety governance. If you ever need to talk to the regulator, or worse, if you need to defend an engineering choice after something goes wrong, you must speak the language of SFA, RP, and SSA. It's non-negotiable.
Okay, let unpack this a bit more then. This isn't just like a suggestion or best practice. It's a legal mandate. There are real teeth, real penalties for getting it wrong. Where does this powerful, non-transferable duty actually come from?
Right. It comes from essentially two layers of law. You've got a general foundation and then very specific rail requirements built on top. The baseline starts with the Work Health and Safety Act, the WHS Act from 2011.
Ah, okay. So that's the one that covers basically every workplace, right? Doesn't matter if it's a railway, an office, a factory.
Exactly. The WHS Act lays down that general duty for any person conducting a business or undertaking PCBU is the term to ensure the health and safety of their workers and, crucially, anyone else affected by their activities, like passengers or the public near the line.
So that covers things like providing safe equipment, safe ways of working, a safe environment, training, supervision, the basics.
Yes, the fundamental baseline duty of care for any business.
But railways, they have unique risks, don't they? High speeds, complex signals, the way trains and track interact. It feels like the general WHS Act might not be quite specific enough for those kinds of high-consequence hazards.
And that's precisely why we have the second layer, the Rail Safety National Law, the RSNL, from 2012. This law brings in the specific, much more detailed, and frankly, much higher safety duties tailored directly to the unique risks of running a railway.
Okay, so it builds on the WHS Act.
It does. And critically, the RSNL doesn't just point the finger at the main rail transport operators, the RTOs, the ones with the accreditation to run trains. It explicitly pulls in all the associated industry participants.
Right, you mentioned the supply chain earlier. So the people designing the signals, making the track components, the contractors doing maintenance work, they're all caught by the RSNL's specific duties too.
Absolutely. If you're making a safety-critical part or installing track or doing maintenance, you fall under the RSNL and it's SFARP duty. You can't just say, oh, I only have to worry about the general WHS Act. No, the specific rail law applies to your work. This is a really significant point, especially for companies maybe not fully grasping their role via safety interface agreements.
And just for context, this unified national approach, it's relatively new, isn't it? Before 2013, things were different.
Oh, massively different. It was, frankly, a mess. Before the RSNL came into full effect around 2013, you were juggling something like 46 different state, territory, and Commonwealth laws and regulations. Multiple regulators, different rules depending on where you were. Incredibly complex and inefficient.
Wow, 46.
Yeah. So the RSNL created one single national regulatory system. That move hugely improved efficiency. It allowed for national accreditation, so operators didn't need separate approvals everywhere, and it meant safety investigations and oversight became consistent under the national regulator. For an engineer today, it means the standard you work to in, say, Queensland is the same as in Victoria or WA. Consistency.
Okay, that makes sense. So the RSNL sets the duty. Eliminate or minimize risks SFARP. How does an RTO or anyone else with that duty actually show they're doing it? What's the practical mechanism?
The RSNL requires them to create and maintain a robust safety management system, or SMS. This isn't optional. It's the mandatory way you demonstrate compliance. And that SMS has to embed the SFAR principle into everything it does: design, operations, training, maintenance, everything.
And what are the absolute must-have parts of that SMS that engineers really need to get their heads around?
Well, it covers the expected things.
Yeah.
Processes for identifying hazards, doing proper risk assessments, implementing controls, and then monitoring how well they're working. But the legally vital bits also include clearly defined roles and responsibilities, detailed procedures for internal audits, really strong change management processes.
Change management. Okay, that sounds important.
Crucial. And, very importantly, a genuine commitment to continuous improvement, learning from incidents, from new data, from new technology.
Now, you mentioned documentation earlier, and this seems to be where the rubber really hits the road for accountability, especially for engineers doing the assessments, the documentation duty.
Yes, this is absolutely central. It's Section 100 of the RSNL, and it fundamentally shifts the burden of proof if something goes wrong. Duty holders must keep incredibly detailed records, not just of the risks they found and the controls they put in place, but also the documented reasons for rejecting potential controls. Even if the final decision is, you know what, our existing measures are enough, or we're not going to implement that suggested control, you have to write down why.
Wow. So let's say I'm an engineer, I look at a possible upgrade, maybe a new type of sensor, but I decide maybe it's too expensive or maybe it's not quite right for our specific trains. If I don't write down why I rejected it, what happens?
If there's an incident later and your safety assessment comes under scrutiny and you can't produce that documentation explaining why you rejected that sensor, well, the legal assumption flips.
How so?
The courts and the regulator will likely assume that because you didn't document a reason not to, that control probably was reasonably practicable, and you should have implemented it. The lack of documentation basically acts as evidence against you. It implies negligence.
So the justification I write down isn't just good engineering practice, it's literally my legal defense.
Exactly. This requirement transforms SFARP from just a concept into a rigorous evidence-based process. And that's precisely what SSA is designed to deliver. Your engineering notes, your justifications, they become critical legal documents.
Right, so because everything hinges on SFARP, we really need to dig into what that objective legal test actually involves. As we said, it's not about gut feel, it's not subjective, it's about what a reasonable, competent person or company in the same situation with the same safety duty would do.
Okay, and that means we can't just guess. We have to systematically apply that 5-factor test, the one laid out, I think, in Section 47 of the Act. Let's walk through those 5 factors because they sound like the checklist every decision needs to pass.
Absolutely. They are the core of the SFARP assessment. The first 2 are pretty standard for any risk assessment. Number 1, the likelihood of the hazard or risk actually happening.
Okay, how likely is it? And number 2, the degree of harm that could result if it does happen. Now, in rail, given the potential for high speeds, mass transit, heavy freight, that second factor, the potential consequence, always carries immense weight. A derailment, a signaling failure, these things could be catastrophic, so that automatically pushes the need for strong controls much higher.
Right. High consequence potential is almost a given in rail. So likelihood and degree of harm. What's next?
Third is the state of knowledge. This is about what is known or reasonably ought to be known about that specific risk and about the ways available to eliminate or minimize it.
What does it mean in practice? ought to be known.
It means you have a positive duty to stay informed. You need to actively consult with your workers. You need to be aware of and generally follow relevant industry standards like those from standards bodies or rail safety groups.
Mm.
You need to look at incident data, both yours and others. And you have to pay attention to any guidance the regulator puts out. You can't just claim ignorance if a known solution or a better control method exists and is reasonably accessible knowledge within the industry.
So, if there's a known technical fix out there, maybe something developed overseas even, I have a legal duty to at least investigate if it's suitable for my situation.
You absolutely do. This factor forces organizations to keep their knowledge up to date. It prevents saying we didn't know when they reasonably should have. Okay, number 4 is the availability and suitability of controls.
Meaning, do the controls actually exist and do they fit?
Pretty much. Are the engineering fixes or operational procedures actually available? Can you buy them? Can you implement them? And then are they suitable for your specific context? A control designed for a low-speed tram might not be suitable for a high-speed line or vice versa, but you have to assess that suitability properly.
Which leads us nicely to number 5, the one that often causes the most debate. Cost. The gross disproportionate cost test.
Ah, yes, the cost factor.
Yeah.
This is where SFIRP really shows its teeth, its rigor. The law sets up a clear hierarchy here. Your first obligation always is to eliminate the risk, if at all possible.
Get rid of it completely.
Yes. If you truly cannot eliminate it, you can't eliminate the risk of a train moving. That's inherent. Then you move to minimization. And when choosing controls for minimization, you have to prioritize those that are most effective and reliable. Often this means using multiple controls, what we call layered defenses, to tackle both the likelihood and the potential consequence.
Okay, layered defenses. Now back to that cost factor. Let's say I identify a safety control. It might reduce a particular risk by, say, 10%, but it costs $500,000 and maybe the budget's tight this year. Can I put that control on hold because my company can't easily afford it right now?
This is probably the single most critical misunderstanding about SFIRP. The answer is emphatically no. You cannot defer or reject a reasonably practicable control simply because of budget pressures or because it impacts profitability.
Really? No leeway there.
The legal test is not can the business afford it. Safety must come before cost, unless, and this is the only exception, the cost of implementing that control is proven to be grossly disproportionate to the safety benefit it delivers.
Grossly disproportionate. Okay, that still sounds a little subjective. How is that defined? What makes a cost grossly disproportionate?
It's a very high bar. It involves a complex weighing exercise, but essentially, the cost has to be massively, overwhelmingly out of whack compared to the risk reduction achieved. Think orders of magnitude. Spending billions to reduce a tiny, almost theoretical risk might qualify. But implementing known, available technology to address a significant, recognized hazard, that will almost certainly not be considered grossly disproportionate, no matter the price tag, within reason.
And this is the absolute key point, isn't it?
It is. The duty holder's capacity to pay, their financial situation, is legally irrelevant when determining if a control is reasonably practicable under the SFIRP test.
That's a really stark line in the sand, especially for businesses.
It is. It's the foundation of the safety standard we operate under. If a control meets the SFIRP criteria, it passes that 5-factor test, it must be implemented. And if a duty holder genuinely, truly cannot afford the controls needed to meet the SFIRP standard for their operations, well, the unavoidable legal conclusion is that they shouldn't be conducting that hazardous activity in the first place.
You can't operate if you can't afford to be safe enough.
Precisely. You don't get to choose profit over the legally required level of public safety and transport.
Okay, quickly then, what about different terms? We sometimes hear ALARP used, particularly from the UK or Europe, as low as reasonably practicable. How does that compare to our SFAP? Are they the same thing?
It's a common point of confusion. While the underlying legal test of reasonably practicable is often very similar in practice, the frameworks have slightly different origins and conceptual approaches. SFAA, under our RSNL, focuses directly on the effort required have you done everything reasonably practicable. ALARP often involves thinking about a target level of risk.
And ALARP uses that risk triangle concept, right?
Yes, traditionally ARP is visualized with a triangle. At the top, you have the intolerable zone risks so high, you basically have to stop unless you can immediately and drastically reduce them. At the bottom, the broadly acceptable zone risks considered so low, you generally don't need to do more unless it costs virtually nothing. And in the middle, this big ALARP zone.
And the duty there is?
To reduce the risk within that middle zone to all ARP, meaning you spend time, effort, money, until the cost of doing more becomes grossly disproportionate to the tiny extra safety benefit you'd get.
So how does our SFAR standard interact with that ALARP triangle idea? Can we use the triangle?
While many practitioners find the triangle a useful internal tool for prioritizing where to focus effort first, you have to be careful. The legal standard under the RSNL is always SFAR-RP, based on that 5-factor test. Critically, the RSNL doesn't formally recognize a broadly acceptable zone where you can just stop trying. You have a continuous duty under SFAR-RP to keep reducing risk, always asking, is there anything else that's reasonably practicable we could do now? Especially as technology or knowledge improves, you can't just hit a point on a triangle and say, job done, if there are still reasonably practicable steps available. The legal obligation remains SFFP, regardless of where you might plot it on a risk matrix.
So the law gives us the minimum standard, the absolute floor we have to meet. But you mentioned history earlier, and it feels like history gives us the moral drive, the why behind the discipline of SSA. It pushes us towards constantly doing better, doesn't it? And often, tragically, that push comes from learning hard lessons.
That's absolutely right. These legal frameworks didn't just appear out of thin air. They were often shaped, tragically, by major accidents, by catastrophic failures that showed the old ways weren't good enough. Looking back at some key events really underscores why proactive, rigorous SSA is so vital. We should probably touch on 2 major Australian rail disasters that serve as stark reminders.
The first, which is still the worst in terms of lives lost, has to be Granville in 1977.
Granville was just horrific. 83 people lost their lives, over 200 injured. A packed commuter train derailed on a curve and slammed into the supports of an overhead road bridge, causing the bridge deck to collapse onto the crushed carriages below. The immediate trigger was found to be poor track condition, specifically issues with track fastening on the curve.
Just a technical failure then, worn out track.
Well, yes, that was the immediate cause. But the investigation dug much, much deeper. What it uncovered was a systemic breakdown in the entire maintenance system. It wasn't just a few loose bolts or worn sleepers.
How so? What was the systemic issue?
It was about the processes, the culture, the management. Inspection regimes were inadequate, relying too much on visual checks where more detailed assessments were needed. The reporting lines for defects were weak, and there was clear evidence that essential maintenance work was being deferred, pushed back, often because of cost pressures or operational scheduling demands.
So the organization's own safety systems were failing.
Fundamentally, the safety management system they had back then, if you could even call it that, was completely incapable of managing the long-term health of safety-critical infrastructure like track. Granville forced massive changes in engineering standards for track, in inspection frequencies and methods, and crucially, in the safety culture and management accountability across the entire rail network. It was a brutal lesson in the need for systemic safety assurance.
And then, more recently, the waterfall disaster in 2003. That seemed to highlight different kinds of failures, didn't it?
Yes, waterfall, where 7 people died, was a really critical lesson, particularly around human factors, system design, and organizational culture, all things SSA is meant to address. The initial focus might have been on the driver, who sadly died, but the inquiry quickly revealed multiple overlapping systemic problems.
Such as?
There were issues around the driver's medical condition, yes, but critically, the investigation highlighted known deficiencies in the design of the deadman system, the vigilance control device meant to ensure the driver is alert, or, if not, to automatically stop the train.
So the safety technology itself wasn't robust enough. It didn't properly account for potential driver incapacitation or fatigue in that specific train design.
Exactly. The system had known weaknesses in preventing that kind of accident if a driver became incapacitated in a certain way, and concerns have been raised before but hadn't been adequately addressed using that SFARP lens. But waterfall was more than just technology. It also exposed deep-seated problems in the organization's safety culture.
Like what?
Risk management processes were found to be weak. Training wasn't always sufficient. And perhaps most worryingly, there was evidence of a degree of complacency. A sense that because certain known risks hadn't led to a major disaster yet, they didn't need urgent SFARP-level attention. Waterfall really hammered home the need for proactive safety culture, for human-centered design, and for rigorous auditable safety management systems that genuinely manage risk, not just document it.
It's sobering, isn't it? Even with these huge, tragic events driving improvements, we still see persistent harm on the network. SSA isn't just about preventing the next Granville or waterfall, it's also about dealing with the risks the railway faces every single day interacting with the public.
That is the ongoing challenge for everyone in rail safety. If you look at the fatality data reported nationally, say from 2016 to 2024, it's a stark picture. We're still seeing, on average, around 83 fatalities reported each year associated with rail operations.
83 a year, even after all the changes post-Granville, post-waterfall.
Now, when you break that down, the largest proportion, tragically, around 85% of those nearly 750 deaths over that period are suspected suicides. That's a huge societal issue that railways grapple with. But beyond that, in that same period, there were still 66 trespasser fatalities, 28 people killed in collisions at level crossings involving road vehicles, and 16 pedestrians killed at crossings.
So those interface points, level crossings, people trespassing remain major, persistent risk areas.
They absolutely do. And this ongoing persistent harm profile really underscores that SSA can't just be about the technical integrity of the train or the track systems in isolation.
When it has to look outwards, towards community-level controls, towards interfaces, and constantly checking that the controls we design for the physical system actually work as intended out there in the real world with unpredictable human behavior.
Precisely. The moral drive for SSA is twofold. Learn the systemic lessons from history to prevent catastrophic failure, and apply that same SFARP rigor to manage the predictable yet tragically persistent human interface risks we see day in, day out.
Okay, so if the law sets the requirement, then system safety assurance, SSA, is the practical technical discipline. It's what gives you the operational edge by proving you've done your due diligence. And it absolutely cannot be an add-on at the end. It has to be woven through the entire life cycle of a system.
From the very beginning, like first sketches on a napkin stage, pretty much. From the initial concept design, right through development, commissioning, operations, any modifications you make later, and even thinking about how you'll safely dispose of the asset eventually.
We know you can't just bolt safety on later, but how does an RTO or a designer make sure safety is genuinely baked in right from the start?
It starts with integrating what's called safety in design. Even at the preliminary hazard analysis stage, you're thinking about safety. SSA needs to be applied to basically any change that could conceivably impact safety. That means changes to services, modifying assets, bringing in new tech like signaling systems, and definitely for major new projects like building a new line.
And the level of effort varies.
Yes, the depth of the SSA work will naturally scale with how new or complex the project is. A minor software patch needs less exhaustive analysis than designing a whole new type of train. But, and this is critical, the SFA standard itself never changes. You always have to meet that reasonably practicable test, whether it's a big project or a small modification.
Okay, for our engineering listeners then, what are the core technical activities? What does doing SSA well actually look like in practice?
It always kicks off with thorough hazard identification. And this has to be broad, not just what if the axle breaks. You need structured methods, things like functional failure analysis, FFA, maybe fault tree analysis, FTA, to systematically look for hazards related to human error, potential misuse of the system, what happens in degraded modes like power failures, environmental factors like flooding, and especially those tricky interface hazards.
Interface hazards, like between old and new systems.
Exactly, like how does a brand new digital signaling system interact safely with 30-year-old rolling stock? Or how does the track system interface with the power supply? Those interfaces are often where risks hide.
So you end up with this presumably huge list of potential hazards in a hazard log. What then? How do you structure the proof that you've dealt with them, SFARP?
You build what's called a structured safety case. This is the master document, the core argument, that presents all the evidence showing the system is safe. SFARP for its intended operation. It needs to be built on objective, verifiable evidence.
It's supported by
that detailed hazard log tracking every hazard, the controls put in place, and the justification. You also need records proving you actually implemented the controls, evidence from testing and verification activities, and often for more complex or novel systems, an independent safety assessment, or ISI.
Okay. And sticking with complexity, once a system is up and running, things change. Components get upgraded, procedures get tweaked. That management of change, more process you mentioned earlier, sounds vital for keeping that SFIRP status valid.
It's the lifeblood of ongoing safety assurance. Honestly, any change, however small it might seem, that could potentially affect safety, must go through a formal MUSA assessment. RTOs have to evaluate all changes, and they often have specific triggers that require notifying the regulator, things like introducing a completely new type of train, making safety-critical software changes, or significantly altering key operational rules. You can't just tweak a procedure in a manual without properly assessing and documenting the safety implications, SFARP.
That makes sense for adding something new. But what about the other way around? Sometimes new technology might seem to make an older safety control redundant. Can you just remove that old control, maybe save some maintenance hassle or cost? Say, removing an old physical interlocking system because a new digital one does the same job?
Removing existing controls. That's where you need what I call the reverse SFARP guardrail. It requires extreme caution and rigorous justification. You can only really justify removing an existing safety control under very limited circumstances.
Such as?
Maybe the old control genuinely conflicts with the new system and causes new hazards. Or perhaps its maintenance cost has become truly astronomical for negligible safety benefit compared to the new system. But the fundamental legal test is exactly the same, just in reverse. The removal must not result in the residual risk level becoming unacceptable, i.e., it must still be SFARP after the removal.
So let's take an example. Maybe replacing physical signal cables with a new, secure wireless communication system. How would an engineer justify removing those cables?
They'd have to do a full safety assessment before the removal. They'd document the cables as an existing control. Then they'd analyze the risks created by removing them: loss of physical path, maybe vulnerability to interference, etc. The justification would need to demonstrate, with evidence, that the new wireless system, including all its associated safeguards like encryption, signal redundancy, power backups, provides an equivalent or demonstrably superior level of safety overall.
So you need to prove the net result is still safe, SFARP.
Exactly. You have to document that the final combined residual risk after the removal remains SFARP. It's essentially building a safety case for decommissioning or removing part of the system, and it needs just as much rigor as adding something new.
And for the really big stuff, building a new metro line, major high-speed rail upgrades, how does the regulator guide those huge projects to make sure SFA is embedded from day one?
Yeah, the national regulator has specific major projects guidance. They place a huge emphasis on getting involved early. They expect the project proponents to embed that safety and design philosophy right from the concept and feasibility stages, not trying to retrofit safety fixes onto a nearly finalized design, which is always more expensive and less effective.
And they often require independent checks.
Yes, for complex major projects, they almost always mandate an independent safety assessor, the ISA role we mentioned, sometimes even requiring what's called a shadow operator function.
What's the IS's job exactly? What are they checking?
The ISA is there to provide an objective third-party check on the whole SSA process and the resulting safety case. They review everything to make sure it's been done competently, rigorously, and completely. They check the hazard log is thorough, the risk assessment methods are sound, and crucially, that the claims made in the safety case about achieving SFA are actually backed up by solid, traceable evidence. They're applying that same 5-factor SFA test, but from an independent standpoint, free from potential project or commercial pressures.
And the shadow operator? What's that about?
That's often brought in on very large, complex projects, especially new lines. It's usually a team or consultant with deep operational and maintenance experience. Their job is to look at the design from the perspective of the people who will eventually have to run and maintain it day in, day out for decades. They ensure that practical things like access for maintenance, reliability under real-world conditions, and safe operational procedures are considered early in the design, long before concrete gets poured. It helps avoid building something that looks great on paper, but is a nightmare to operate safely or efficiently.
Okay, we've focused a lot on the RTOs, the main operators, but you said earlier this duty is shared. Who exactly holds this responsibility? It must be tempting for an RTO to think, well, I've contracted out the design, so safety is the designer's problem now.
That's a really common thought.
Yeah.
But it's a legally flawed one. Yes, the duty is shared across the chain, but that ultimate accountability for the safety of the overall railway system, that always rests with the accredited RTO. They set the requirements, they manage the interfaces, they have to assure the whole system is safe. SFARP. You cannot contractually transfer your primary legal duty away.
So even if I have a safety interface agreement, a contract with a supplier that says they are responsible for the safety of their widget, I, as the RTO, am still on the hook if that widget fails and causes an accident.
Potentially, yes. You might have transferred the task of delivering a safe widget, And the supplier certainly has their own direct legal duty under the RSMP to do that SFARP. But you, the RTO, retain the duty to ensure the overall system, including how that widget integrates and performs, is safe SFARP. If the supplier fails, both they, for their direct failure, and you, potentially for inadequate specification, oversight, or integration assurance, could be found liable.
Okay, can you spell out the duties for the supply chain members then? Designers, manufacturers.
Absolutely. The RSNL is very clear. Designers, manufacturers, suppliers, installers, repairers, maintainers, they all have a direct, explicit legal duty to ensure, so far as reasonably practicable, that the thing they are designing, making, supplying, or working on is safe and without risks to health when used for its intended purpose in a railway context.
So direct culpability.
Yes. If a designer chooses the wrong material spec, if a manufacturer has sloppy quality control, if an installer wires something incorrectly, they are directly breaching their own SFA right duty under the rail safety law. The RTO's critical role here is managing that whole ecosystem, setting crystal clear safety requirements, defining roles and responsibilities properly in those safety interface agreements, and then, this is key, actively monitoring and verifying that their suppliers and contractors are actually meeting those requirements. Audits, inspections, verification checks.
And what about the person actually driving the train or fixing the track, the rail safety worker on the ground?
They have crucial individual duties too. Every rail safety worker has a legal duty to take reasonable care for their own health and safety, and also to take reasonable care that their actions or omissions don't adversely affect the safety of others. Plus, they have a duty to comply with any reasonable instruction given by the RTO that allows the RTO to meet its duties under the Act. Basically, follow the safe procedures laid out in the SMS. Their actions are the final step in making sure the engineered controls actually work in practice.
And even the public has a role.
In a way, yes. Where the public interacts directly with the railway, like at level crossings, they also have responsibilities, like obeying signals and signs. This highlights why SSA often needs to consider controls beyond just the railway boundary, like public education campaigns or better road infrastructure at crossings, managed through interfaces with road authorities.
So it's a whole system of shared overlapping duties. Now, putting aside the legal stick and the moral imperative for a moment, you said SSA offers a commercial advantage. Why should the finance director or the CEO really care about investing properly in a robust SSA program? It sounds expensive.
It's an investment, not just a cost. Good safety is genuinely good business. The business case really stacks up in three main ways. First, and most obviously, avoidance. Effective SSA drastically cuts the likelihood of catastrophic accidents. That avoids the immediate, massive financial fallout compensation, repairs, fines, but also avoids huge reputational damage, loss of public trust, and the incredibly costly and disruptive investigations and enforcement actions that inevitably follow major failures.
Okay, avoiding disaster. What else?
Second is performance. This is often overlooked. A system designed and maintained with safety rigor, using SSA principles, is almost always more reliable, more available, and easier to maintain what engineers call RAM. Reliability, availability, maintainability. Why? Because the processes that ensure safety often eliminate the same kinds of design flaws or maintenance errors that cause breakdowns and service disruptions. Better SSA means fewer failures, fewer delays, smoother operations, less unscheduled maintenance. That saves money and improves customer satisfaction, offsetting the upfront investment.
Makes sense. Better engineering is better engineering.
Exactly. And the third area is confidence. Demonstrating a strong, transparent, evidence-based commitment to safety through SSA builds and maintains public and governmental confidence. That's absolutely vital for securing long-term passenger numbers, freight contracts, and ongoing political support and funding for rail. In the long run, safety assurance underpins the entire social license to operate. So just to kind of pull all that together from our deep dive today, we wanted to really get into the why behind system safety assurance, that non-transferable legal and moral duty. And the absolute cornerstone is the legal standard, SFARP, so far as safety are practicable, proven by applying that objective 5-factor test.
Right, and the mechanism, the mandatory way you prove you're meeting SFAFP under the Rail Safety National Law is by having and using a robust safety management system, the SMS.
Exactly. And the mindset, the approach every engineer manager needs, has to be one of continuous improvement, driven partly by the law, but also by that moral imperative, remembering the lessons from tragedies like Granville and Waterfall.
And we learned just how critical that documentation duty is, Section 100. You absolutely must record your reasoning, not just for the safety controls you do put in place, but crucially, for the ones you considered and rejected. Without that justification trail, you've basically got no defense if things go wrong.
Yeah. SSA is that whole life cycle discipline. It forces you to think about controls as systems themselves, to actively look for and avoid common mode failures, to actually verify controls work in the real world, not just on paper, and never ever rely on just a single safety barrier for anything with high consequences. Your goal is to build that defensible safety case, backed by evidence, justifying every critical decision.
So meeting that legal duty, demonstrating insafari, building that legally sound system, that's really the baseline. That's the minimum standard expected of us as professionals in this industry.
It is the floor.
But earning and keeping the public's absolute trust by showing them visible, evidence-based safety assurance, properly documented, fully justified, constantly reviewed through the whole life of the system that feels like the ceiling. That's the level of excellence we should all be striving for.
Well said.
Okay, as we wrap up, here's a final thought to chew on, especially for those of you designing or managing the railways of the future. We established very clearly that an organization's capacity to pay is legally irrelevant to the SFERP test. If a safety control is reasonably practicable, it must be implemented regardless of the company's bank balance. So here's the provocative question. If a business gets to a point where it genuinely cannot afford a necessary, reasonably practicable safety control, what does that stark legal reality actually say about its fundamental right, its ongoing license to operate a public transport system? Something to think about as you go out and build the next generation of safe railways.